An experiment was conducted on the surface of the moon to investigate the motion of a small sphere. The sphere, mass 50 grams, was projected horizontally from a point some distance above the surface of the moon. Its subsequent motion was monitored by taking a photograph of the sphere using a series of flashes of light at intervals of 1 second. The first flash occurred at the instant of projection. The photograph superimposed on the grid is illustrated in figure 2.1. By considering the horizontal distance moved, showed that frictional forces opposing the motion were negligible. So from the data in figure 2.1, we can get this table. So the horizontal distance between the dots are approximately constant, 4.25 meters. So hence the velocity is constant. This can only happen when friction is negligible. Calculate the horizontal component of the velocity. So using the 7 dot, the distance traveled is about 29.5 and the time is 7 seconds, so it's 4.2 meters per second. Use figure 2.1 to determine the vertical distance traveled during the first 7 seconds of the moon. So from the figure, the distance is, for the 7 dots at 7 seconds, that is 40 meters. Calculate the value for the acceleration of free fall on the surface of the moon. So s equals to ut plus half at square. The initial speed is, vertical speed is 0. So we end up with this equation, and a is 1.63 meters per second square. The loss in potential energy of the sphere during the first 7 seconds. So loss in potential energy is mgh, mass is 50 grams, the g is 1.63 and h is 40. So we end up with 3.26 joules. Show that the kinetic energy of the sphere after 7 seconds is about 3.7 joules. The loss in potential energy is equal to gain in kinetic energy. This is due to conservation of energy. So the loss in P is 3.26. The change in the kinetic energy will be final kinetic energy minus initial kinetic energy. So we know the initial speed, so we can find the initial kinetic energy. So solving the equation, we get the final kinetic energy to be about 3.7 joules. Determine the magnitude of the velocity of the sphere 7 seconds after projection. So from the kinetic energy, we can find the velocity. And v is 12.2 meters per second. Determine the direction of the velocity of the sphere after 7 seconds. So after 7 seconds, the horizontal component of the velocity is 4.2 meters per second. And we get the speed as 12.2. So theta will be given by this expression. And we get 69.8 degrees and is below the horizontal. On your answer paper, sketch the path of the sphere indicated by figure 2.1. So this is the path of the sphere. Add to your sketch 2 further lines showing the path of the sphere if the moon have an atmosphere. Label this path A. So this is the path. If you have an atmosphere, then the X projection will be smaller because of the air resistance. The experiment repeated on a planet which had no atmosphere and where the acceleration of free fall is less than that on the moon. So that will be path B. If it's a less than that on moon, so the vertical drop will be slower.